So I'm going to talk about bad ideas, and I'm going to, first of all, suggest to you that we are all here because of one piece of technology. And it's this piece of technology, which is a hand axe. This particular piece of technology is in the British Museum in London. It's about 1.5 million years old, and it's this piece of technology which is the most important thing that humans have ever invented. Why? Because it's with this we modified our own evolution. We changed our genetics, and we did that by carving the flesh off bones of animals which had died in the savannah. Before that, we were vegetarians, and with that we built the lipids and the proteins which make your brain and my brain. So that is the hand axe. And what is extraordinary about the hand axe is that here's another hand axe, also in the British Museum, which is dated 1 million years later. And if you look at it, it's the same size, the same shapes, the same working. It has not changed, because nobody, no pre-human, had the idea of attaching it to a stick. And once you've attached it to a stick, you've got a completely new technology. We were very, very slow intellectually. We didn't understand that then you've got a spear, you've got an axe, you've got an axolotl, you can move things at incredible speed at long distances, and you can kill at long distances as well. Now, I want to go through to where mankind first started, and I'm not the first man, by the way. This is simply the savannah in East Africa. This is in the Rift Valley, and I'm holding in my left hand the skull of Australopithecus afarensis here, and the skull of Homo erectus. The brain capacity of that skull is about 450 milliliters, and Homo erectus is 900 milliliters. So in the time of just under 1 million years, the pre-human brain has doubled in size. Modesty forbids me to mention there's a third brain on the photograph. But the modern human brain has tripled in size. It's about 1,370 milliliters. And it turns out that the brain is about 70 milliliters larger in men than it is in women. They're looking very pleased with themselves. But actually, the reason why the male brain is bigger is because we can't ask directions to where we're going. There's no evidence of any difference in ability or intelligence, and it's important to know that. But basically, that brain is really the brain of Homo sapiens. And what I've done here is to draw a line over the top representing the time that our species, with the genes which make our brain, has been on the Earth. It's about 100,000 years. And there's a lovely little line there you can't see, which is about the last 400 years. But before I mention that, let me just say that while I was posing for this photograph, there was a buzzing from this pocket, and it was Richard Dawkins phoning me from Oxford. You may have heard of Richard Dawkins. He was trying to persuade me to sign a letter to the newspapers arguing that we shouldn't teach creation, we should teach evolution. And I was pointing out that I was teaching evolution by having this photograph taken in the middle of nowhere. Extraordinary thing is that my phone never works in London, and it was working in the middle of nowhere, in the middle of Africa. Anyway, what I think is very, very surprising to think about, that if you take the last 400 years, that short time, which is just that tiny fragment up there, we've started to do the most extraordinary things. Hamlet was written by Shakespeare in 1599. In 1609, Galileo showed the moons going round Jupiter, and he showed by the process of observation, empirically, that in fact we are not the center of the universe. And this is the letter he drew at the time to demonstrate that on each night that he observed, the moons had moved in relation to the planet Jupiter. Before that, of course, there was the notion that we were the center of the universe. Well, take the lights down, I think, if you don't mind, rather than flashing them around. Take those lights off the screen, if you would. Thank you. And then, Around about 1800, we have the first locomotive, the first motorized transport. This is the steam engine, which is made by Trevithick in the village of Camborne in Cornwall, which drives up a hill. And this, of course, is the first time that we drove under our own steam. That's in about 1800. And then 25 years later, we have this phenomenon. Perhaps you could turn the sound up a little bit, if you would. Can we have the sound up? Sound increased? Thank you. Bit more. Can't hear it. Thank you. So, this counterpoint of Beethoven's Opus 131, the C-sharp minor late string quartet, is one example of what is happening not just in technology, not just in science, but also in our culture. Because what is happening here, of course, is something which Beethoven is describing better almost than anybody else, is the human mind. So the interesting thing is that your genes have not changed roughly in 100,000 years. Our species is defined by its genes. But what has changed, of course, is not the brain, but the mind. That is developing faster and faster. So that now we've landed on the moon, we've made computers, and in our laboratories at Imperial College, we're making living organisms out of the building blocks of life. We're actually able to take DNA, we're able to take bits of cells and build them together and make an organism which will breed, which will replicate. Something which would be completely unthinkable. And the extraordinary thing is this. You know, when Athens was created and people built the Acropolis, they would have said, well, this view would never be changed. Now, of course, the view of Athens is changing so rapidly that you don't know where it'll be in 5 or 10 years' time. And in terms of science, we don't know what our children will be doing, what technology they will have. So how we handle that technology, how we understand it, becomes more important and increasingly essential for our society. And this is why. It is because of things like this. This experiment is going on in Northern California, near San Francisco. It's about an hour's drive away, where what they are doing is building this vast cavern, which is a bit higher than this theatre, a complete globe surrounded by 2 foot of concrete all the way around, about just under 1 meter of concrete, and it's in another building about the size of the largest football stadium in the world, which is surrounded by 3 foot of concrete. And the sphere is pierced with 192 holes through which the most powerful lasers ever produced by humankind are actually functioning. When these lasers are switched on simultaneously, they actually consume or produce more energy than the entire national grid of the United States of America for a brief fraction, a tiny fraction of a second. And all these lasers are focused on this point here. What they're focused on is this capsule, this gold capsule, through these holes. And the exquisite engineering means that those lasers are focused in that brief moment of time on a pellet of water which is 2 millimeters in diameter and frozen right down almost to absolute zero. It's enriched with extra protons because it has some isotopes, usually of deuterium or tritium. The precise physics doesn't matter, and indeed, I'm really not interested in the physics, to tell you the truth. That's not why I'm discussing this. Though the physics is exquisite, actually, as it turns out, this experiment has not worked. It's extraordinary that it's got some useful information, but it turns out that the European attempt to make nuclear fusion of protons, has been much more successful both in Britain and in France, where at least we have managed to produce some energy. This machine has not even made enough energy to light a light bulb. But it's interesting because, you know, the laser was first thought of, theoretically, by Albert Einstein. in 1905. So long ago, 110 years ago. But nobody knew or thought to make a laser until about 1960. 50 years it took to make a laser. And when they made a laser, what was it used for? Nothing. Nobody could think of a use for it. Now, every one of you in this room uses a laser every day of the week. You use the internet. You use the fiber optic cable, incidentally invented at Imperial College where I work, down which a laser shines to send instantaneous messages at the speed of light around the world for news gathering, for commercial activity, for communication of every sort of kind. You use a laser for your DVD, for your CD machine. You use a laser when you check out of the supermarket to read the barcode. You use a laser to operate at the back of the eye to make sure the retina is properly attached, or perhaps, in our case, in my sort of field, to try and operate on the fallopian tubes or the uterus, or perhaps even the gallbladder for surgery. We use a laser for measuring distances. We use a laser in computing. In my laboratory, and I'll show you a photograph at the very end, we use the laser for the confocal microscope to give exquisite photographs which you cannot get with a light microscope. It is one of the 10 great inventions, and it was never thought of at the time when the first science was discussed, and nobody realized how valuable the laser would be. But interestingly, there's something else about it. When I asked Ed Moses, the director of this institute in Livermore, in California, how it was he'd managed to persuade the least scientifically literate president of the United States to give him $125 million a year for an experiment that didn't work. He leant against the machine and he said, well, it's easy, isn't it? It's easy because it's all part of our nuclear weapons program. And that's really interesting too, because of course, for every piece of technology which is an advantage, there's a downside as well to that technology. And that is part of bad ideas. Take the motor car. Here you've got Edward VII's motor car. And this is in about 1910. He had his first motor car in 1905. And of course, the people who are complaining that the motor car was absolutely destroying their environment. They didn't know about climate change, but of course it produced the massive oil market in Texas. Here you see Columbus Joiner's first derrick, which was producing a gusher in the 1930s, when oil was being sold at 2 cents a barrel. Water, by the way, cost 50 cents a barrel at the same time. And within a year, 1 million barrels of oil were being produced because of the motor car. But we never understood that transport was actually really dangerous because of the effect on climate change. And now, of course, with the aeroplane, it's even more dangerous, not because of bombing, not because of war, but because with the aeroplane, we become really vulnerable to pathogens across the globe which can be transported within hours to our own environment, which threaten our own immune system, which of course has got no resistance. Why do you think Europe was so frightened about Ebola fever? They were frightened about Ebola not because we were worried about the West Africans. That really wasn't, it was self-interest. It was because we were frightened we might catch it if it was transmitted in droplets in the breath. We were lucky it wasn't. And the same applies, of course, to many other viruses and some bacteria. And of course, now, of course, the result of the burgeoning motor car has resulted in Fallujah. Fallujah has been destroyed several times, and of course, in the Iraq War twice, a main oil-producing region of the world. So the consequences are massive. Now, one of the areas, of course, I really want to talk about is my own area, which is genetics. And this painting of the Oberstein altar, which is in Mainz, in Germany, shows something very interesting. It shows Pontius Pilate washing his hands with Jesus Christ being led away to be scourged. He's really given up all interest. He's not prepared to take responsibility. What to me is fascinating by this painting, and it's something which I've not seen ever described by art historians, is that the important thing in this painting is not Jesus Christ, and it's certainly not Pontius Pilate. It's the central figure. It's this dwarf. Look at that dwarf. That dwarf is painted in a lighter color. The dwarf has got a misshapen face. He's got no neck. He's got a bent spine with uneven shoulders. He's got an abdominal hernia, or possibly an enlarged liver, and he's got short legs, and he's accompanied by an animal, because he is seen by the painter not to be truly human. The dog represents his lack of humanity. Why is the Oberstein master in 1400 AD painting it like this? He's trying to demonstrate that the tortures of Jesus Christ are the work of the devil, something which is subhuman. Because this person, and I go around looking at that galleries a lot, trying to make diagnoses, and this is absolutely characteristic of a disease called mucopolysaccharidosis, which is a genetic defect in the DNA. And if you think that this is just a construct of my imagination, let me show you another painting. This is in Aachen, and it shows you Jesus being shown to the baying crowd. Ecce homo, behold the man. And when you look at his skin, you can't see it very well in this light, but it's really scourged. He's got bleeding, and he's got scourges all over his body. You can just about see that there. He's chained at the wrists. There's Pontius Pilate displaying Jesus. But the interesting figure, again, is in the center of the painting. The center of the painting shows this baby. Look at the face of that baby. Does that ring any bells with you? Even with my rather poor reproduction in this light, you can see very clearly that that baby has got Down syndrome. This is a Mongol child. Again, subnormal intelligence, subhuman, a genetic defect, an extra chromosome, chromosome 21. And to make the point, the artist has taken this bent back of Jesus with the bent back of the baby. And the baby is chained by the wrist to a monkey to make quite certain, there's no doubt, that this is not a proper human either. And the monkey is picking the lice out of the baby's hair. So again, this is the work of the devil. And let's just take a third example. We could go on and on with medieval painting. About 50 years later, in 1485, this is Sophie of Bylandt's painting, so we know at least the artist. And this is Jesus being mocked by these people who are all rather deformed. He's got a withered arm, do you see that? But the most impressive deformity is the man in green. The man in green has got his body facing one way and his head facing the other way. Is that biologically possible? Yes, it is. There's one disease where that could happen, and it's a genetic defect. It's a DNA defect, osteomalacia. This is osteogenesis imperfecta, almost certainly. I can't think of another reason for it. And he's handing Jesus a wand made of a reed. This reed, of course, is mocking him. It's a scepter. He's offering him this diseased man's scepter. This, ladies and gentlemen, is a twisted joke. It's a twisted joke. And the point I'm trying to make to you, that I could have taken Roman times, of course I could have taken many civilizations, but I've chosen Western civilization more recently from the Renaissance, or the late Renaissance, or the late medieval period, because I want to demonstrate to you that there is this concern about our genetic differences. We are obsessed with our differences, and this is the reason for giving you this talk at this time in Greece at the Athens Science Festival. And I have to say that one of the real concerns I have is that the whole issue was finally raised in a big way by academics in Britain. This is Francis Galton, who published his work on intelligence, and he argued that as he was a cousin of Charles Darwin, that we ought to try to promote survival of the fittest. He wrote about this a great deal. He argued that genius was inherited. In fact, it's true that some of us are more clever than others, but the differences in intelligence between all of us is extremely slight. It's not massively different genetically. It's massively different as a result of nurture. We can't change our genes, but ladies and gentlemen, we can and we should improve our nurture. That it will be part of my message. But here you see Francis Galton, who was very intelligent. He read Latin and Greek at the age of 5. He was certainly reading Thucydides by the age of 8, and Ovid. And he was certainly an explorer. He was one of the great mathematicians, but his big work was on intelligence, and he became what was effectively the first professor of genetics before genes had been actually coined as a word in the late 1890, round about then, at University College in London. And you see the self-satisfied smile on his face. This is the sort of thing he wrote. It's a very bad reproduction, but you can see that he's talking about people who we want to promote and have them breed. These include people who are painters, literary people, politicians, of course. He thought politicians were highly intelligent. Perhaps they were in those days. I don't know whether there's been a massive change. And these were people he would want to prevent from breeding. These people were regarded as socially inadequate persons who should be prevented from breeding. They included people who were poor, people who were on the rates, who were supported by the community. And here you see what happened. This resulted in the eugenics movement. And the eugenics movement was massive. The eugenics movement was espoused by all these people and many more. George Bernard Shaw, Winston Churchill, John D. Rockefeller, Bernard Russell, one of our greatest philosophers, probably the greatest philosopher of the late 19th, early 20th century in Britain, Theodore Roosevelt and H.G. Wells. And at Imperial College, where I work, I blush to say that just about 100 meters from my office, they had the first international Congress on eugenics just before the Great War, before the First World War, and this had a massive impact. It resulted in people from all around the world recognizing they needed to control their population to ensure, with social engineering, we encouraged the right people to have babies. In America, it hit off in a very big way. Harry Lachlan was appointed by the President of the United States to screen all immigrants to make certain they didn't have any risk of tainting the genetic pool in the United States. And we have here Carrie Buck. Carrie Buck was a particularly sad figure. Carrie Buck was born from a mother who abandoned her at the age of 3. Her mother was not married and was thought to be of subnormal intelligence, but there's really no evidence of that. Her mother was in care, and Carrie was also put in a care home as well. And at the age of 12, Carrie was raped and had a baby, another girl. So there were 3 generations of girls, all regarded as being of subnormal intelligence, but no evidence that they were. And I have to say, at this point, I blush for my profession, the medical profession. Rather like scientists, medics are very often very certain of where they think things are right and are quite certain they have the right solution. And Dr. Bell pursued Carrie Buck through the courts of the United States of America to have her sterilized without consent. And indeed, this went on, but before that happened, the Racial Integrity Act was enacted, which meant that miscegenation between different races in the United States was a criminal offense. And eventually, before the Supreme Court of the United States of America, one of the most famous of all American judges, Oliver Wendell Holmes, made this judgment in Buck and Bell. He said in 1927 that it's better for all the world if people like this are sterilized. It's like taking out their appendix or giving them a vaccination, because 3 generations of imbeciles are enough. And rather shockingly, ladies and gentlemen, look what happened in 1945 and 46, because then that judgment was cited by the defendants at the Nuremberg trials in their defense. You've done it in America, why shouldn't we do it in Germany? And this, by the way, is what was happening in Germany. In 1936, that man who was screening for genetic ability, Harry Lachlan, was given an honorary doctorate at the University of Heidelberg. At the same time, in 1936, this poster went up. It costs you, it's saying, 60,000 Reichmarks a year to keep this invalid, this cripple, alive, this cripple in German, alive. And if you want to know what to do about it, it's your money, read Neues Volk, our magazine. We know what happened to people like that in Nazi Germany in the 1930s, by the end of the 1930s. And of course, by 1942, we have horrible pictures like this. This is Commandant Hoss in Auschwitz, smoking a cigar with his friends, with his guests in the background, none of whom would survive. And this, of course, is a member of the medical profession, of whom you will have heard, I suspect, Dr. Mengele. Dr. Mengele was doing unspeakable experiments to prove his genetic theories. So he was taking twins like this, in this case, non-identical twins, and doing experiments without anesthetics, operating on them, trying to transplant tissues between them sometimes, all sorts of really horrible things, never with an anesthetic. And he made children like this, those that survived. A few did survive, that's how we know about it. Most of them, of course, did not survive, and it's too horrible to think about. You would have thought that after the Holocaust in 1945, there would be no further scientific justification for this kind of activity. That the idea that science is absolutely presenting a complete truth about the nature of our humanity. But this picture is taken from the Carnegie Institute in the 1950s. I can date it by the number of chromosomes, because in fact, this person who's drawn this karyotype has got the number of chromosomes right, so it's quite inaccurate. He's got it wrong, rather. He's drawn 24 pairs and not 23 pairs. So this would be about 1952, 53, and he's trying to demonstrate completely subjectively that, in fact, a Negro is in some ways genetically different from a white. And he's drawn those pictures of babies as well to demonstrate that. And there was this notion, of course, that the black person was inferior. Now, where do I come into this story? You very kindly introduced me as a surgeon, and one of the things I did was to repair fallopian tubes. I saw a lot of Greek patients who used to come for tubal surgery. I used to have a teacher who used to stand in front of the class and say, "What am I? What am I?" What he was a womb and two tubes. And what I was operating on was on the tubes to try and join them together. And the internal diameter of the human fallopian tube is very, very narrow. It's only about 0.5 millimeter in diameter. So it requires very delicate stitching, and I was using needles and thread which were so delicate, which we made ourselves in the laboratory because nobody would make them for us. They're so delicate that when you drop them, they just floated on the airwaves in the laboratory. And you were lucky if you could see them, which was quite interesting. And however, I did that piece of technology with my friend Robert Winston, who died just a month ago, died of cancer. So that's a bit of a loss. But eventually I was able to join up the fallopian tube, and I found that within a year or two, by the early 1970s, I was getting floods of women who were coming to see me to have their sterilization reversed. Now, it was curious because most people were perfectly happy to be sterilized, but here we were seeing several hundred. And I rather belatedly published this paper in a British journal some years after I'd made the observations of the first 100 women. What was interesting was that all these women were requesting reversal. They came from all over the United Kingdom, and sometimes from outside as well, because they didn't feel a proper woman. They'd lost all self-respect. During sex, they felt like an empty vessel. Many of them broke up with their partners. They stopped having orgasm. They found that actually they were so damaged psychologically because they couldn't have babies anymore, that they didn't feel feminine anymore. To them, this was an absolute disaster. This was a major injury. And with a bit more probing, of course, I found that almost universally, the reason why these women had been sterilized was because of a perfectly legal reason. Because in 1967 in Britain, we had passed in Parliament the Abortion Act, which allowed people to have a termination of pregnancy for social reasons. And the surgeons were saying to these women, yes, I'm prepared to do your termination of pregnancy, but of course on condition that you are sterilized at the same time. That is the power of the medical profession, I regret to tell you, and that power of the expert meant that these women were effectively being coerced into being sterilized. So, because you couldn't get pregnant again, because you obviously couldn't support another baby, and I have to tell you something really shocking. I can't see all of you around this audience, but a number of these young women, when they were sterilized, were certainly no older than many of the people at this festival. They were 15, 16, or 17 when they were sterilized by these surgeons. That was a common story. So you see, it's very easy for experts with their power to attitudinize, and we have to recognize that. It still goes on. This governor of this prison is saying it costs $147,000 a year over a 10-year period. It's not a huge sum to sterilize these women before they leave prison, because we can't afford, obviously, to have those babies being born outside when they can't look after them. Now, in Europe at the moment, we're going through quite a turmoil, as the rest of the world is. This is in France, and you'll recognize Marine Le Pen.
Essentiel pour notre liberté individuelle, pour l'autorité de l'État, pour la défense de la laïcité, pour la défense de la loi.
This woman got 30% of the vote in the last elections. 30%.
Dans mon rôle de responsable politique, en ayant dénoncé cette violation de la loi, de la laïcité, de l'autorité de l'État, et donc je vais venir expliquer au tribunal que je n'ai commis absolument aucune des infractions que me reprochent l'ensemble des associations lourdement subventionnées, chasseuses de primes, aux ordres du pouvoir.
So she is, of course, invoking la loi, the law, essentially. And this is pretty typical of the right wing. You have your own right wing in Greece, we have our right wing in England, and they are truly frightening. If you're not convinced by that, let's look at a photograph of the person who might become the most powerful person in the whole of the Western world.
Because of this deal. So now you have him saying, we're going to take in maybe, I mean, the number I'm hearing, it's inconceivable. You know, it started off with 10,000. The other day I heard 200,000. We're going to take in 200,000 Syrians or wherever they come from. We have no idea. There's no identification, there's no anything. And I'll tell you right now, and I'm putting everybody on notice, and hopefully this gets outside of this room, and I guess it will with all these crazy cameras going back there. I'm putting the people on notice that are coming here from Syria as part of this mass migration, that if I win, they're going back. They're going back. I'm telling you, they're going back.
And you know what, ladies and gentlemen, it's not the statement that's frightening, it's the chairs of the populace in the background. That, I think, is truly horrifying. And let me just show you one third example. I could show you innumerable examples, but this will do of a 3.5-year-old child with an announcer on television. This is broadcast in Saudi Arabia.
Last year from Ikra, a Saudi-funded TV station widely shown in Muslim countries.
اسمك ايه؟
بسملة.
بسملة، عندك كام سنة؟
3 سنين ونص.
انت مسلمة؟ بسملة، انت تعرفي اليهود؟ بتحبيهم؟ لا، ما بتحبيهمش ليه؟
كده.
عشان هم ايه؟
هم قردة وخنازير.
عشان هم قردة وخنازير؟ مين قال عليهم كده؟
ربنا.
قال عليهم فين؟
القرآن.
الله عليها، ربنا يكرمها، ويعني الواحد فعلا ما يتمناش من ربنا ابدا بنت اكتر.
Sad little girl. Imagine an official announcer on television saying that about any particular ethnic group. This is not an anti-Muslim statement, believe you me, it isn't. But this is truly shocking, because this kind of indoctrination of young people goes on with a number of different ethnic groups around the world, not just people who regard themselves as speaking on behalf of Islam, but it happens elsewhere as well, and it's really, I think, truly shocking. There is this deep xenophobia, which almost seems to trickle into our consciousness. And let's take the two people who, in fact, discovered the structure of DNA, Jim Watson and Francis Crick. This is what Francis Crick said. The main difficulty is that people have to start thinking out eugenics in a different way. Jim Watson was banned from the United Kingdom last time he came because he said that blacks were less intelligent than whites. Don't think for a moment that we as scientists, ladies and gentlemen, don't have a major responsibility for how the public, the politicians, and the rest of society thinks. We have a massive influence, and we need to be very well aware of that. Hence the value of things like science festivals. And I must congratulate you on the Athens Science Festival. It's really, really exciting. You should be very, very proud of what you've done. So this is terrific. It's a wonderful venue too, I must say. Let me look, though, at this obsession with genetics. This is a broadcast in the year 2000. We've lost the sound. What happened? There should be some sound. Oh, perhaps there isn't. Never mind. Doesn't matter. Look, it's President Clinton announcing the sequencing of the first human genome, all right, in the year 2000 with Francis Collins and Craig Venter. And here he's coming. And this is unprecedented. A public broadcast of this scale in Washington to demonstrate a scientific biological achievement of so monstrous, so large, that in fact has the president announcing it, is extraordinary. And down the line, at the other end of the television, also on screen, is Tony Blair and also the Wellcome Trust, who funded part of this work with Michael Dexter. And there is Clinton. I'll tell you what he says. It doesn't matter. We can't hear it on the tape, and it's not very important. What Clinton says is that by God's grace, he uses a religious argument, by God's grace, we have drawn the most important map ever drawn by mankind. Tony Blair down the line says, this tells us more about our humanity than any previous human achievement. And Michael Dexter, the man who funded it from the Wellcome Trust, or part of it from the Wellcome Trust, said, this is more important an invention than the invention of the wheel. Let's look at those three statements very briefly. Let's look at the map that's been created. Let me just tell you, the map of Washington, D.C. is a good deal more useful. More useful. Because the map that we now have in the genome, of course, is changing all the time. We didn't understand epigenetics. We didn't realize there are well over several million particles in messenger RNAs, for example, which have an influence on hereditary, together with other proteins as well. Tony Blair, bless him, said this tells us more about our humanity than any previous achievement. I would argue that my start with Hamlet tells us more about our humanity. If you want another example of our humanity, why not try Lysistrata? Why not try Sophocles? I mean, why not try Aristophanes? Here we have all sorts of examples. And with regard to the wheel, well, if it's a more important invention than the wheel, it hasn't turned very much. And here is a colleague from King's College London, who's just published this and got himself a bit into trouble by a number of people, but it's really shocking he could even agree to say this, that he's saying that the welfare state is resulting in people passing on this genetic predisposition for living on the welfare state, and that actually we need to do something about their genetics. And he's arguing they should not be allowed to breed. The problem, of course, also is that reproductive biology has a massive market. You've seen that in Greece. In some cases, of course, it happens in every society, unfortunately. People are desperate to have children, and they're prepared to pay anything. And sadly, of course, the avarice which accompanies that leads to an inflated market. I bitterly regret what has happened in Britain, but there it is. I can't say what's happened in Greece, but certainly in Britain, it's been, I think, very shocking. And of course, people would like to have better children too. If we could actually change the genes of our children, why wouldn't we want to sell that? There is a real question there. So one of the issues, of course, is pre-implantation genetic diagnosis, which was one of the technologies which we were responsible for in my lab. This is biopsying an embryo. We're able to remove a single cell, sequence the DNA. This was well before the genome was sequenced, by the way. We didn't need the sequence of the human genome to make this diagnosis. And we were able to screen this embryo to ensure that this woman who'd watched her baby die over 3 years would not have another baby die. So what we did was to take a droplet of acid and suck out a single cell. We did all sorts of experiments to show this was safe, and it took 5 years to make sure that we could sequence the DNA in a single cell. That was quite a problem, but there were 4 of us that did that. The paper in Nature was by Alan Handyside, Kate Hardy, my Greek colleague Helen Contagiani, and myself. And one of the things I've always been really pleased about is the number of Greek scientists that we've had in our laboratories, and they've been very fine people to work with. But anyhow, eventually we had this result. This is Lisa and Harriet, and they were called by the press the perfect baby. The question is this eugenic? But the difference here, I think, is the notion of consent. Here we are certainly trying to help a family that has taken a decision that this is risky because we might get it wrong, we might not make a diagnosis correctly, and there might be risks in doing this, but this brave woman, Mrs. Edwards, was prepared to try it. And by the way, of course, Lisa is not a perfect baby anyway, because she's got this blemish on her chin. And that's not because she had a cell taken away, it's because she fell over before the photograph was taken. But now, ladies and gentlemen, we've got to the stage where we can start to make sperm out of stem cells. So here is a mouse tubule with stem cells which are developing into sperm. You can see the tails. And that raises some really interesting questions about how we can manipulate reproduction in the future. Can we make a human egg? Almost certainly we might be able to. But one of the issues, of course, is that during meiosis, during development, the egg throws off half the set of chromosomes. It has to. It can't be fertilized with two pairs of chromosomes, so 1/2 of the pairs are randomly extruded by the polar body. So you have, in this polar body, a complete set of chromosomes. You have the entire genetic material for an individual. So what you could do is to do this. Using a laser, you can make a little hole in the zona pellucida, and you can suck off a polar body. And you could inject that into an egg.
You're insecure, don't know what for.
You Make Me Beautiful is the song. I'm rather friendly with Harry Styles, which is why I couldn't not put this on. But the issue is extraordinary, and we can also inject genes. This is Cal Reedhead injecting DNA. It's very inefficient into a fertilized mouse egg. But of course now what we're trying to do is to do this in my lab in a different way. And recently we've published a couple of papers on modifying sperm, and that is highly efficient. So we can do this. So we can actually make, we've modified the sperm in this male. We have a dominant gene for a black coat. All his daughters have a brown coat because the sperm we've got into his stem cell, the stem cells which become the sperm, have been modified genetically. And we can go a stage further. Here we have a large animal. We've been working with pigs because we want to modify the genes of pigs because we want to try and modify the cell surface antigens genetically so that then we would have pigs whose organs would not be rejected by the human immune system if they were transplanted. We would have a supply of hearts, a supply of livers, a supply of lungs, and of course of kidneys. Now, that seems to be a very useful use of this technology. I've set it to Schubert, the slow movement from the quintet, because there's the pulse of time on the bass. But Schubert's music is also about uncertainty. Because, of course, if we can modify a pig, ladies and gentlemen, why not modify another large animal? The success rate of this gene insertion is certain. We've published 50%, but it's probably about 80% efficient. And it will get more and more efficient, I think. So why not, with gene editing techniques which are now coming on with CRISPR, why not try to modify the human embryo? And so there's a very interesting question. And to conclude, I want to prevail on you to look at one last very short video, because I think this video explains why we have to be very much aware of the risks of doing that. This is Leonard Bernstein, and I want you to watch the way he does something which is absolutely human. It's not superhuman, it's human. He's using his ability to communicate when he's conducting the 88th Symphony of Haydn. We might make better humans, but they might not be so good at communication. You change one gene, you have a knock-on effect down the line. I think the unpredictability of this technology is something we need to be very, very much aware of. So I want to conclude with this brief group of aphorisms for the scientist. Remember, first of all, that most discoveries are heralded by exaggerated claims. That secondly, most discoveries turn out to be useful for something entirely different from what they were intended. That most discoveries have beneficial applications which were not envisaged at the time. And bear in mind that democratic governments, even the most democratic governments, don't use science wisely. And that we constantly reinvent the same inventions. You know, the first in vitro fertilization certainly wasn't done in London, Cambridge, or Oldham. It was done in 1900. And it's amazing how far back it traces when you really look at the records. And scientists are not always objective. And finally, ladies and gentlemen, we can't predict the future. Thank you very much for listening to me.